Okay, so we are going to, always takes a minute for my computer to catch up to me, be talking about some basic limits. There we go. And let's start with one that looks like this. Now remember, we're looking for the y values and where we expect the y values to be. If we have a function where the function is just f of x equals 3, what would be the y value when x equals 2? Keaton's got it? Everybody else is giving me a stone-faced, I'm not awake yet look. Keaton's even giving you the answer. Well, he was. There we go. I want to hear it from more people. Alright, Annie's got it. JC's got it. Somebody said it. Was it Francisco? Alright guys, you gotta give me more than what you're giving me today. I need more of a reaction, because right now, if I had to assign participation points at this moment, almost everybody would be losing out on some, because I'm asking questions and then half of you aren't even looking at your screens. There's a lot of, I don't know, there's other things going on. I don't know if it's just that you're dead. I don't know. But I need more than I'm getting from you already. Okay? Alright, what's the y value when x is 2? Everybody show me with your fingers. And Claire, I still need to see more from you because your camera's pointed at your ceiling. Alright. Okay, Claire, can you change the angle of your camera at all? I do agree with you as well. You have something where your y value is constant. Your y value is 3 everywhere. So therefore, shouldn't matter what x value you plug in. You get that out. What's convenient about this problem is we just go off the graph where we think about, well, when I plug in my x, what do I get out? And this is a case where my actual equals, what was it I was calling it last week? Of the expected. Remember, actual is if we do like f of 2. Expected is if we do the limit as x approaches 2. It's expected based on the numbers that are around it. It certainly won't always be that this is the case, but in this problem, and for the first ones we do, we're going to look at cases where the actual and the expected are the same thing. Okay, and I know I've got a few Wi-Fi issues, so looks like I've got people that'll be popping on and off as we go. Okay, another easy one. Tell me either by turning your microphone on or tell me in the chat, and I want everybody to give me a response. Tell me what it is that we get as this limit. Aurora's got it. Andre's almost got it. It will be a number. There we go. Annie's got it. Satya. Kaomi maybe almost has it, but maybe if she goes higher, she actually has it. It might be her name's covering up part of her answer. Alright. Claire almost got it. Nelina, Hunter, you got it. And JC, I think I already said you maybe, but you got it. Okay, this is another one where the actual equals the expected, because all we do is we plug in the -4 where the x is, and we get our limit out here is going to be the expected value, the actual value, f of -4. Again, that is not always going to be the case. What about something that looks like this? Alright, Keaton and Annie have it. Satya's got it. JC's got it. Gabe's got it. Mia and Nalina have it. Francisco's got it. Kaomi's got it. Okay. Almost too easy, right? Let's do another couple too easy ones before we jump into the more difficult algebraic stuff. And remember, if I'm writing it on the screen, I do expect you are also copying it into your notes. You learn more, much, much more, from writing something out than you do from hearing, or certainly even just seeing it. Okay, let's see, this one's next. Alright, go ahead and give me an answer on this one. In the chat, or if you can figure out how to do it with your fingers, that would work too. Keaton's got it. I think Annie's got it. Trisha's got it, and Alina's got it. Aurora might have it, but I don't know my sign language well enough. Or yep, Aurora, you've got it. Hunter's got it. I've got to watch both the chat and the windows to see who's miming it to me. Alright, JC's got it. Mia's got it. Again, super, super easy. Trisha, thank you for letting me know. Yeah, I know it's not just one or two people. Okay. If you can plug in, what I'm trying to get at right now is if you can plug in the number, just plug in the number. Which, for actually an incredible number of limits, you can do. Now, those aren't necessarily always the ones we're going to give you because they're not the most interesting. But if you can plug in your number and find f of that number, that's where we're going to take it. So on one like this, if this is what you gave me, and I know I didn't hear from everybody, but those of you that gave me answers, that is what I heard from you, that is what we'll take. And Claire, if your internet's cutting out, you do have permission to keep your camera off, but let's see, as much as you guys can give me your camera, it just really helps for feedback, since I do go off visual a lot. Alright, what about that? Trisha, you're close. Mia, you got it. Nalina's got it. Satya's got it. Francisco's got it. Keaton, Aurora have it. JC, Gabe have it. This one does have an asymptote, but it doesn't prevent you from finding the answer. Hunter, you've got it. Jared, you can simplify your answer. But you've got it. Kaomi's got it. I think I caught everybody that's in the chat. Brooklyn, you've got it. And Brooklyn especially, thank you for Brooklyn and Claire for using the chat. Andrew's got it. Okay. One more super easy one. Test your trig knowledge a little bit. See if you remember the unit circle. Not so sure how you would mime this one out, but I'm looking forward to seeing how you might creatively do this. Keaton's got it. Nalina, so that is the location on the unit circle, but that's not going to be how the answer. When we're using radians, we're going to see something else come with it. Andrew's got it. Mia's got it. Francisco's got it. Sathya, not quite. When you plug the pi in the cosine, you can simplify it, it'll go away. Jared, as a decimal, you've got the approximation. And Gabe, you use the decimal approximation as well, I'll take it. Nalina's got it. Now this one does require remembering. Annie, yours is off a little bit. And Aurora, yours is off. My guess, Annie and Aurora, you're probably using calculators that are set to degrees instead of radians. Which is an important little side note for the lesson right now. Is in calculus, which is something I have not brought up before now. Your calculator should always be in radians unless the problem specifies degrees.
Wait, I forgot how to set your calculator to radians.
Which calculator do you have?
A TI-84.
84? Okay, so you want to go... Conveniently, 84 is the one I have too. Let me put that on the screen. And then I'm asking Lori, I asked Lori this weekend if I could get emulators for the Nspire as well, in case any of you have that one. Okay, I opened it, but where is it? Strange. Okay, my computer's telling me that it's opened, but I don't see it anywhere. Oh wait, there we go. It's hiding behind my Zoom stuff. It's also telling me I haven't activated my license yet, which is not true. Alright, well if that doesn't work, let's see if I can go off memory. If you have the TI-84, I can't write today, then what you're going to want to do is, I believe it's the mode button at the top. It's like the second from the top. And then it will have a radians degrees. It does not have gradients on the TI-84. You just want to make sure that the box or the highlighted is around the radians, and then hit enter. Alright, and Aurora, your answer looks a lot closer now. So on this problem, again, it's one we can just plug and play. You plug in your pi, and from the unit circle, which in my class was the very last thing we did last year. If you had either of the Math 3 honors classes, you should have seen it probably about midpoint last year, but I know if you had LUTs, that it is something that you guys have already shared with me, that you didn't spend a whole lot of time on this trig. because it was all taught during the period where we had the transitions. So what we know from the unit circle is that cosine of pi is the same thing as -1. So this is the same thing as -pi. Now, I did get several people give me -3.14159, blah, blah, blah. Or choosing to round it wherever they so desired. That's okay too, but I will say, for what we're doing, this will be the more exact answer that we're going to be looking for. We will want it in terms of pi, not usually in terms of the decimal. Any questions on all of that? Okay. Let's make it more difficult then. This is where limits really come into play. What do you do here? First of all, just go ahead and plug and play. Tell me what you get. Annie, I saw part of yours, but then your screen froze. Might be my connection, because all of your screens are freezing. Alright. Annie, Kaomi, Nalina, yes. Andrew, yes. Francisco on top, yes, but on bottom, what do you get? Keaton, yes. Mia, yes. Trisha, you got what's on top, but I want what the bottom gives you. Hunter, yes. Francisco, yes. Trisha, yes. Andrea, if it came out to any other number, there's a possibility of it. There we go, Francisco. Got it. If I plug and play here... yeah, no, that happens, Andrea. The world explodes. Perfect. That's the answer I'm looking for. So, something to remember. This 0 does not matter. At most, it would make my whole function equal 0, but 0 is still a real number. That's okay. This, I have big problems with. Remember, we talked about, I think it was last week, that the world explodes every time you divide by 0. And your calculators have the safety feature built in where it'll say undefined or does not exist or error, so it keeps you from exploding up the world, which I appreciate. So, this right here is a big problem. But, if we go back to our lesson from last week, see, this is an old function I don't need right now. If I go back to my function from, or what I learned last week, I know I can graph these things, and I can see my limit from this. First of all, what shape do we see out of this function?
A parabola.
A parabola. Is that what you would have expected from this equation? It's not what I would have expected. I was nodding. Sorry to Kaomi and Brooklyn. Both wrote parabola in the chat. This looks like a rational function to me. I never would have expected a quadratic out of it. Now this one is a very special one. See if I can get it. Right on. Oh, right. I almost had it. Right there. At this point, I actually have a hole. It's undefined. It's defined everywhere except for the point we need. At the point we need, it's undefined because if I tried to plug that point in, I would get an explosion of the world. So, we taught you last week how to handle this with the graphs and tables. What we're going to do this week, and I am going to spend all week just on this section to give us plenty of time with the algebra and do a little review as we go. What we're going to spend time with on this problem is polynomial division. And there are 3 methods for polynomial division, 2 of which I believe you know. Some of you might also know the third. So we could use long division. We could use something called polydoku, which I do want to point out. Ames is one of the only schools I have ever encountered. Ames is the only school I've encountered that uses polydoku. When you go up to your college classes, they won't necessarily know what that means, okay? And then the third one that's commonly taught in colleges and other schools, but I've not seen at Ames, is called synthetic division. They all do the same... Oh, what was that?
I've done synthetic.
You've done synthetic? Yeah.
Isn't it supposed to be easier than long division?
It's faster. It only works... So this one has a special case. This one only works if dividing by a binomial of degree 1, which is a fancy way of saying you're dividing by ax plus b. If you have an x squared, it won't work. If you have a full trinomial like ax squared plus bx plus c, it won't work. Where on these will always work. So I think that's why CPM specifically chose not to teach you synthetic division, because it's a method that it works for the most commonly used problems, but it doesn't always work. I know for me personally, I usually will pull out synthetic division because that's the way I learned, and that's the fastest. I have my lessons set up to do polydoku, just because I know that's what we've probably practiced with the most. But I can switch between any of these if you guys do have preferences. So, show me with your fingers, and Claire and Brooklyn put this in the chat. Would you prefer that I do my example with long division, 1, polydoku, 2, and I'll even say I will do synthetic division 3, but I kind of don't think you guys know that one, except for Melina. So show me with your fingers which one you'd prefer me to do the example with. Okay, yeah, that's what I figured. Just at Ames, we see it the most. Oh, and Brooklyn wants the 3. I can go back and do videos on 1 and 3. Well, Brooklyn, it's not necessarily that you need to know it in college. All of these will still work in college, but if you talk to your professors and you say, oh, well, isn't that polydoku? They're going to look at you like you're crazy. And I'm telling you now, you need to know to tell your professors. It's another way to do the same thing. But tell you what, I will do polydoku. That's definitely what I got the most votes on. But Claire and Brooklyn and somebody else, I don't remember who, I will go back and do some videos on these other methods and show you how they work. Not expecting to be pros at them, but just show you how they're similar to what you already know. Okay. So, I'm going to write my problem down here again because I'm about to scroll. With polydoku, remember, whatever goes on the bottom of the fraction, that's what goes off to the side. And whatever was on top, that would be your answer after you multiply two things together. We put it down below, and an important step here is you do need to remember for every x value that is missing from your problem, you do need to put in a placeholder of 0 times that number of x's. Alright, and Keaton, you got the answer early, but you got it. Yes, and Alina, if you weren't at Ames last year, you definitely probably have not learned this lesson. Like I said, Ames is the only school I know of that teaches this method. For me, you are welcome to use anything you want. Synthetic works fantastic with these problems. Actually, that'd probably be a good thing. Maybe I'll do videos on all three, since you weren't here last year, to help with that. Alright, another helpful hint as we go is whatever number this is on top, that's how many columns I break this into. Most of the time I see people just make too many or not enough columns and they adjust as they go, but the hint is whatever this number is, that's the number of columns. And what you're going to do is you're going to take your first term and you put it in the first box. And once you have that, then you're going to say, okay, what do I multiply this thing by, this x by, to get x cubed? It's all an area problem. It's a length times a width. So x times what gives me x cubed? Keaton's got it? Jared, you took it all the way to the end. I just need the first thing. Melina's got it, which is super good job, since you weren't here last year. So x times x squared gives me x cubed. Now we're going to take that x squared times negative 1. What's x squared times negative 1? We've got some masters of miming here. Got it? Got it? Whole slew of you. And then this is the part that people would forget last year, in my class sometimes, is then you need to add the diagonals together, and your negative x squared plus whatever goes in that box has to equal the x squared term from down below. So what would have to go in this diagonal box? Keaton, mime it again. Okay. And Alina's got it. Aurora's got it. Francisco's got it. Maybe some other people because the chat's going kind of quick. Okay. Andrea, Kaomi, you've got it. And then we repeat our process again. So there is kind of a pattern to this, that you put your first thing in the box, then you go up, then you go down, then you go diagonal. Then you go up, you go down, you go diagonal. So, tell me what goes here. Keaton? Annie's got it. Andrew, Kaomi, Francisco. Me, it'll be the opposite. It'll be a positive x. I know I'm kind of making this sloppy with everything going on, but x times x will give me x squared. Down here below, then we'll get the negative x. What goes here? You guys are going fast enough. I think a lot of you have reviewed this enough. Kaomi's got it. Keaton's got it. Annie's got it. Melina's got it. It'd be an x here. What goes here? Keaton's got it. JC's got it. Aurora. Kaomi and Andrew. And what is 1 times negative 1? Keaton's got it. Kaomi and Francisco. Aurora. Or sorry, not Aurora. Andrea. Claire, Andrew. Got it. Okay, so what we see here is this tells us that x squared plus x plus 1 times x minus 1 would equal this item. That's how we played with Polydoku for the most part before. But that means also conversely that x cubed minus 1 over x minus 1 equals x squared plus x plus 1. And what's convenient about this is, finish the problem up in this tiny space. We had the limit as x approaches 1 of our original function. Now, I can say that that will give me the same thing as the limit as x approaches 1 of this function, because they are the same place. It does look similar to synthetic. They all are very closely related. And I had some students, I don't remember if it was any of you, but I had some students last year that preferred even the long division over the other two. The other two are shortcuts, but they only work because the long division works. Okay, now we have a function we can plug this into, because remember, these two functions, they equal all of the exact same things. If I type in x squared plus x plus 1, they are in fact the exact same function, with the only difference being this function fills in the hole. So I no longer have to worry about that not existing and blowing up the world. And I'm waiting for you to copy it into your notes. Okay, looking at time, I probably will go over synchronous just a little bit, but what I'm going to do is I'm going to give you a problem to work, and then I want you in the chat or on the screen to tell me the answer. I'm not going to do this one for you. If you get stuck, though, let me know, and I will help you. I'm going to give you a similar problem where we're going to use the division of whatever variety you prefer, and I want you to use it to find the limit. I am specifically only focusing on 2 algebra topics today so that we don't overwhelm you too much, and that's again why I'm splitting up this section over a couple days. So we can do the others on Thursday. Okay. Wave at me if you still need more time copying stuff down. Okay. Your problem. Find the limit as x approaches -3 of x squared plus x minus 6 all over x plus 3. And tell me the answer in the chat or with your fingers.
I have a question. When do you know when to just plug it in, or to find the polydoku thingy?
Well, and I would always start by plugging it in, and if I see a fraction, which most of these will be fractions that give us the problems, what you're going to want to do is first see, can you plug that number in and not get 0? If you get that it does not exist, then you want to switch to using algebra to divide out, or using one of the other methods we come to. Okay, nobody in the chat has given me the correct answer yet. Although, Aurora, if you plug in your number, you will give me the right answer. Okay, Francisco, Andrew, you've got it. Yeah, our answer should not have an X in it. It should just be a number. Andrea, yours is off. Mia, you've got it. JC, you've got it. Keaton, yours is off. Aurora, you've got it. Jared, yours is off. Trisha, yours is off. Keaton, you've got it. Claire's got it. Andrea, yours is off. Jared, yours is off. EJ, you've got it. Annie, Jared, yours are still off. When you get X, you do just need to remember to plug in what X is approaching. So you will get X when you divide. There will be an X involved in that. But your final answer, because you're plugging in -3, you shouldn't have an answer with just X. And Satya, yours is off. Brooklyn, yours is off. Andrea, yours is off. Nalina, yours is off. Andrea, you've got it. Annie, yours is off. And I just did a lot of the problem for you on the board. What I would do is, if you're getting the answer off, check your work against mine and see if we get the same quotient out, same answer out after we divide. Because that would probably be where the mistake would be, is if we're getting something different. Jared, you've got it? And once you get it to a place where you can plug in the X without it getting a does not exist or error or whatever you want, then you are in the place you want to be. Okay, if you need to make any adjustments to your notes, or any additions, go ahead and do that. Because I do have one more technique I'm going to teach you today. Brooklyn, I think you're asking me about this one right here. So what you're going to do is, as you work through the Polydoku, you start by placing your first item. And then you say, okay, I know this is X. X times what gives me X squared, so you get this. Then X, that length times this width gives me this box. So X times 3X gives me, X times 3 gives me 3X. And then this diagonal trick right here, remember, is that those diagonal boxes have to equal your X term from the problem below. So therefore this has to be a -2X in this box. And once I have that, I know that this length of the box was X. We have to find the width to give us the area of -2X. There we go. And I will say too, if your answer does not divide out exactly, if we'd gotten a remainder here, then this would not be the method we would want to use. On purpose, they're going to give us ones where this number matches the final number in your polynomial so that it does divide out without a remainder. Because this trick doesn't work when you have a remainder. Yep. Once you have your function in a place where you can plug in your number, in an equivalent function for everywhere except for maybe at the one point we need. If you see the graphs are the same, basically, then plug in your number that you're approaching and simplify from there. Just like we did with the first problems. You just plug and play. Yep, got it. All right. Wave at me if you're still taking notes, which is fine, if you are. Okay? And then give me a thumbs up when you're finished taking notes. Okay. And Mia, I think you froze. Oh, no, you're just staying really still. Are you still taking notes? Okay. And again, I do have this video. I think I've worked out the kinks to get this video up online. It's your past ones that I'm struggling with. Okay, new technique here. I can see from this problem, I'm not using polynomial division. I don't have a polynomial on top. So it has to be a whole new technique, and this technique is going to be called rationalizing. I'm going to do an example with you for you, and then I'm going to have one for you guys to do, and then we'll be done for today. So on a problem like this, you're not going to necessarily see them a crazy amount in calculus itself, but you will see them. And here in limits, it's going to be an important algebraic topic to cover to get us set for what's coming. Rationalizing is actually still a technique you do use fairly often in upper level math, but it is a method I wouldn't have expect even honor students to have used much last year. You might have. I can tell you I'm pretty positive my kids, I don't remember doing it at all with Math 3. Math 3 honors, maybe. Let me know after we do the problem if it sounds familiar. Now, this method is all based on a very, very simple idea. It's based on your difference of squares. But what's different about it is our terms might be a little bigger and uglier than we're used to them being. But if I see that something has a square root, and I just have two terms, and they're being either added or subtracted together, then rationalization is actually commonly the way you want to go, where you're going to use the conjugate of the thing that has the square root. So a plus b and a minus b are conjugates, which is a word you should have encountered last year. All of you should have. Yeah, I could see it being something you touched on but didn't really focus on. And Aurora, when you say touched on it in terms of the A's and B's, or touched on it in terms of the square root of x plus 1 minus 1? You keep telling me. I'm going to keep going. One other special, really important rule to remember here is legally I can only Okay. Multiply by the number 1. So when I choose to multiply by the square root of x plus 1 plus 1, legally I have to put the same thing down below so that I'm not altering my original values of my problem. It's very, very common. We're actually going to use this trick. I can't even begin to tell you how many times this year we're going to use this trick of multiplying by 1 to change what the problem looks like without actually changing the graph of the value. Now when I do this, upstairs, I now have this. I'm not multiplying anything together really yet. Downstairs, I have this. Not that far. I'm just going to move these out of the way a little bit. Maybe. Sorry, gotta wait for technical difficulties as my computer catches up. Okay. I'm going to use my idea of multiplying through the box method again. But this time I'm not dividing, I'm just straight up multiplying. So the things I multiply go on the outside. And I fill in the box with what I get. Now conveniently, these are the same square root. If they were different at all, I couldn't do this, but because they're the same, I get the square root of that thing squared, which means the square roots and squares cancel. I just get what's on the inside, because the square root of anything squared will cancel the square root and the squared. And then here I have this. Here I have this. And this. And very, very conveniently, what's wonderful about the difference of squares technique is your middle term that you would normally have in any other multiplication of two binomials disappears. Which you can see here, this and this, when I add them together, they will go away because they're the same thing, but one's positive, one's negative. This means that this big, ugly problem simplifies all the way down to that. Or even more simply, as Keaton is putting it, my ones go away. I end up in this case with just x. So now this is the problem that I am dealing with. Brooklyn it is, but because I'm adding, I can choose to drop the parentheses if I want. If I had a squared around the parentheses or any other function, then I couldn't simplify, but in this case, since it's to the first power, you can just drop the parentheses. Now, notice on my limit function, I've got something upstairs and downstairs that are the same. They cancel, and conveniently it's going to cancel out the thing that's being problematic. My x's here go away. And it was that x on the bottom that was causing me my does not exist error in the first place. So I don't have to worry about that anymore. I can now plug in x equals 0 and get out a very reasonable answer. And I think you gave it to me, Keaton. But I know my eyes are kind of darting here and there around the screen. Yep, see it in the chat now. You got it. Okay. Would you put your hand on your head if you've done this before, this whole rationalizing method, and put your finger on your nose if you don't think you have, or if you don't think you learned it well? Okay. I'm sad I missed out on the song. Okay, alright. So that's actually a little better than I thought. I was expecting this one to be foreign to more or less everybody. Sorry. We still will give you plenty of practices. When you plug in the answer, you want to make sure you plug it into... I'm responding to the chat. Plug it into this function. And when you plug it into this function, we get 1/2 out instead of 0. Okay, I'm going to give you a function. I'm not going to work it out for you, but because this method is still kind of new-ish to enough people, or maybe not practiced enough, I am going to write out some hints for you as well. But I want you really to take the reins on this one. Okay. So I'm going to write out a couple notes, definitely to get you started. But really, I'm going to leave this one up to you. And that's all I'm going to give you. Andrew, you've got it? Claire and Keaton, you've got it? Francisco, you've got the reciprocal of it. In some ways you were closer with the first answer. just remember, if you have stuff cancel out between the top and the bottom, you do have to remember to keep a 1 up there. I don't know if that's what's happening, but I know that is what people commonly will do on problems like this. Alright, JC, you've got it. Aurora, you've got the reciprocal of it. Andrea, you've got it. Mia, you've got it. Francisco, you've got it. Aurora, you've got it. They don't always cancel, but they will often enough that you want to always have your eye out for that. Annie, you've got it. I mean, it depends on what you're talking about. When you're talking diagonals, actually, let me come back to you. Do you mean these diagonals? Tell me in the chat. EJ, you've got it. Nalina, you're off by a little bit, but you are very close. Okay, so Brooklyn, in this case, yes. If you're choosing the conjugate, these two will always cancel. I was thinking something maybe with when you're multiplying fractions, like if you have A over B and B over C. I was thinking those kind of sort of diagonals, but that's not what you meant. In this case, if you're using the conjugate of your original, those diagonals always, always, always cancel. Nalina, you've got it? Alright, let's see, Sathya, you've got it? I think I'm still waiting to hear from Hunter, Trisha. Let's see, did I hear from Gabe? I don't think I've heard from Gabe. Jared, you've got it. Trisha, you've got it. I think I'm still waiting to hear from Kaomi. I think Brooklyn. Okay, so after you multiply, it sounds like that's what you're getting from here. When you add them together, you're getting x minus 3, which is correct. What you want to do then is that is what these two together were when you multiplied them. So your problem now would look like x minus 3 over x minus 3 times this stuff. And because you have that x minus 3 on top and bottom, they gave you a problem on purpose that was going to cancel there. Which, of course, remember to leave your 1 up top. If you have your top, everything on top cancel. Alright, yeah. Hunter, Gabe, Kaomi, Claire, I don't remember if I heard from you. Give me an answer in the chat. Claire got it? Okay. And I know I might be missing somebody, but I think that's everybody. How do you feel about a problem like this? Is it challenging enough? Works your brain a little more than the beginning of the lecture? One thing about calculus, taking any calculus class, is you're going to learn math more intimately than you did in any of the other ones other classes put together. Alright, and Hunter, I agree, you just need to now plug in 3 where the x is and simplify that. And Brooklyn, you are close. Yep, you got it, Brooklyn. So I do agree with you that this is what should be the function you're playing with. Hunter, you got it. And the last step, you plug in your x value you're approaching, just like you did at the first lessons, or the first problems we did today. There's your answer. Okay, so what your expectations are for today. I went ahead and moved your current module to the top, so it should hopefully show up that way for you as well. Let me know if it doesn't. But this way, you just, especially as we get further and further in the year, you don't have to scroll and scroll and scroll and scroll to find our work. I noticed that last week, a lot of you neglected to take the quiz. We did have a quiz. We're going to have a quiz every lesson. So if you're one of those people, send me an email with the things you want reopened, and I will reopen it for you, but I'm not going to open it for everybody. I'm only going to open it if you ask. And again, with parent-teacher conferences coming up, always a good idea. So, as soon as we leave, you have a discussion question, just again telling me what you learned in this lesson. Explain in your own words something you learned. You do have a quiz that's based on last time's work. And again, and don't tell me in the chat about the quiz, like email it to me, because I'm going to I always delete the chat at the end of the lesson. And for your homework, again, both of these things are open until Friday. They close at midnight on Friday. The discussion closes tonight. So don't neglect that. That goes into your participation scores, just like showing up to class goes there. If we go to your homework, I do want to just acknowledge I am giving you a fairly long assignment. I respect that. I understand that. But I also will admit I do not feel bad about that, because these problems are plug and play. I believe all of them, and if not all of them, almost all of them, are just the same as your actual value. You plug in the X, you're going to get the answer. There are no tricks to it. But there's a whole variety of functions. When I do the times 3 here, it means multiples of 3. It's my shorthand. So it means do problem 3, 6, 9, 12, 15, etc. All the way up to 42. And then I also don't feel bad because, remember, all of the odd problems answers are in the back of the book. So all of the problems I gave you on dividing out and the rationalization technique, you can check the answers in the back of the book. Now don't just give me the answers, because that's not what I'm interested in. If you're just giving me the answers, I'm not going to give you full credit. Show me the work to get there, but check your answers as you go. Okay, so, like I said, it is a little bit longer, especially because of this section, but there were different things that the sections were, different ways they were asking you the problem, that I wanted you to practice with those different ways of being asked. Do you have any questions for me? Okay, and then just another reminder, I have open office hours, as do all of your Ames teachers, on Fridays from 9 to 11 a.m. So far, it's only been AP Calculus students showing up. I haven't seen any physics students yet at that, so it's just been a study session for you guys. Once physics students show up, then I'll probably make some adjustments and make a physics time and a calculus time. But for now, it's all you guys. And then I will say too, if you want to also schedule outside time, just let me know. If you want to work on homework together over Zoom groups or Discord or however you want to do it, that's fine with me too. I do encourage you to do homework together. Please do the quizzes separately, but homework I don't care. And let me know. You are going to get one more assignment, because on Thursday we'll have an assignment as well that we'll be going over. And both of those I have due then. Well, Thursdays I'll give you a little more time on, but yeah, let me know if there's anything I can do to help, because some of these problems, just like you saw today, some of them are almost too easy, but then there are some that you might get stuck in one or two little places and just need that extra boost, and I'm happy to give that to you.